So in this video we will look at an insertion algorithm for a skip list. This is the standard way to insert elements into a skip list. So let's go for it. So we have insert, which is our function name, and we have our element which we want to insert. Now we want to create a new node to insert into the skip list. So now we say node is assigned a new skip node with the element, and our random, remember we generate a random level. So 1, 2, 3, 4, whatever the level is, we send that in and we create a new skip node with that number of levels. Then we say we're going to go from 0 to the number of levels minus 1, because we're going to go 0, 1, 2, 3, 4, which is going to be 5. If you have 5 levels, it's going to go 0, 1, 2, 3, 4, which is 5. And we're going to initialize our previous array to head. Our previous array will be the predecessor pointers that we're going to have to make point to our new element we're going to insert. So we have to find those. On each level there will be a predecessor to assign to the new element we're going to insert. So then we say we just create a variable with the number of levels in it, and we also assign a variable with the head to traverse or go through the list, because we don't want to destroy or change our head variable. Then we say while our number of levels is still greater than or equal to 0, so we're going to start at levels and work down. If the element that we want to insert is equal to use, which is the pointer within the skip list, dot next of level, so at that level, the element at that point. If it's equal to that, then we know we must return, because then the element is already in the skip list. Else, if the element is greater than the next element at that level, then we know we must go use is assigned use.next at that level, because this element is that we want to insert is still bigger than the element that follows it. So we need to traverse through until we find a point that the element is bigger than, that this element in the skip list is bigger than this element, because then we know we found a point where we can insert it. I'll show an example now. Otherwise, if the element's not bigger, then it's less than, then we say, okay, we have found a predecessor, because then the element we want to insert is less than the element in the skip list at that level, and we decrease the levels and we repeat it for the next level. Then, once we found the predecessor array, which I'll show you how to do now, physically on an example, then we say, okay, we're going to go from 0 to the number of levels, and then node dot next of at that level will be assigned the previous at that level dot next. So what we're doing here is we're making a new node. We're making the new node point where the predecessor was pointing. So we're making the predecessor point to the new node instead of to the one that will come after the new node where it used to point. And then we say previous at that level dot next at that level is assigned node. So make the predecessor point at the new node. So we make the new node point where the predecessor was pointing before, and we make the predecessor point at the new node. So let's look at an example, just to clarify everything. So if I want to insert the number 9, so now I say, okay, my random generator, let's say generated level 3. So now I say number 9, and I say, okay, while levels is greater than or equal to 0, if element is equal to use dot next at that level, that element, is it bigger than? No. So then we say, is it equal to? No. Else, if it's bigger than? No, it's not bigger than. Else, we know we must just say the previous of levels is assigned use. So this will be the predecessor of 9 at that level. And then we can go down one level and we repeat. So now we say if the element is equal to use.next, which is 7, no, it's not equal to 7. Else, if it's bigger than 7, no, it's not bigger than 7. Else, we say previous levels is assigned, no, it is bigger than 7.